Hello, so this is video 3 about questions and answers about natural computation. And the topic for the video today is the fitness sharing concept in a genetic algorithm. So the question is just very easy. Explain what the fitness sharing method consists in a genetic algorithm. So I just tick this as before because I'm quite excited with NoteBookLM from Google, and ask it to make a video that I'm going to show you now.
Today, we are talking about fitness sharing. Now, this is a really clever trick that helps smart algorithms get even smarter. And it does it by teaching them one simple, very powerful rule from nature. Whatever you do, don't just follow the crowd. I mean, think about it for a second. In any kind of race, whether it's in the real world or inside a computer, the whole point is to find the absolute best outcome. But what happens when one pretty good idea gets so popular that everyone just stops looking for an even better one? Well, that is the exact problem that fitness sharing was designed to solve. So, let's dive right in. Section 1, Digital Darwinism's Dilemma. You know, we often think of survival of the fittest as this perfect, unbeatable system. But in the digital world, it can sometimes create a really powerful and pretty dangerous echo chamber. Okay, so imagine you have a really complex problem to solve. A genetic algorithm doesn't just start with one single idea. Nope, it starts with hundreds, maybe even thousands of different potential solutions all at once. It's a bit chaotic, it's super creative, and most importantly, it's incredibly diverse. But here's the catch. As the algorithm runs, one of those solutions might turn out to be just a little bit better than the others. And because of that survival of the fittest rule, the algorithm starts making more and more copies of that one winner. And pretty soon, this single good enough idea just completely takes over. And all of that amazing initial diversity, it's just gone. This whole situation leads to a big problem called premature convergence. The best way to think about it is like a search party that's looking for the highest mountain in a range. They find the first big hill, they plant their flag, they celebrate, and they declare victory. They get stuck on a local peak, and they totally miss the true Mount Everest of solutions that's just over the horizon, all because they just stopped exploring too soon. So how do we stop our algorithm from getting stuck on that first hill? Well, for the solution, we can look to the world's leading expert in managing diversity, nature itself, which brings us to Section 2, the diversity solution. We're going to use a really simple analogy here. I want you to picture a remote island, and this island is full of birds. This island is our problem, and all the different birds, those are our potential solutions. So on our island, there's one type of seed that is just everywhere. It's super common. Naturally, most of the birds evolve the absolute perfect beak to eat that one seed. But now, they're all fighting over the exact same food. The competition is just brutal. But then, a few birds do something a little different. They adopt. Maybe they start eating a rarer kind of seed, or they start eating insects. They find their own little niche. And because they have basically zero competition there, they just thrive. The whole ecosystem actually becomes healthier and more stable because of these unique specialists. And this really illustrates the core idea perfectly. Success isn't just about being good, it's about being uniquely good. It's about finding that uncrowded space where your specific strengths can really shine. So, how in the world do we get our code to think like those smart, niche-finding birds? Well, that brings us right to Section 3, Sharing is Caring, for fitness. And you know, it's pretty amazing how perfectly this whole island analogy maps onto our algorithm problem. The birds with their different beaks, those are our potential solutions. The different food sources, the seeds and the insects, those are the different problem areas or niches. That fierce competition for the popular seed, that's exactly like our algorithm crowding around one popular solution. And a bird that thrives in its own niche, well, that's our algorithm finding a unique and really powerful answer. And this is exactly what fitness sharing is. It's a simple, but honestly a profound change to the rules of the game. So instead of just asking, how good is this solution, the algorithm also has to ask, and how many other solutions are just like it? It actively punishes crowding and rewards exploration. It's basically a digital incentive to be different. Okay, so that's the big idea. But how does it actually work under the hood? Let's take a look at the mechanics, which, believe it or not, are surprisingly simple. It all happens in 3 quick steps. First, for every single solution, the algorithm checks how similar it is to all the others. Second, Based on that similarity, it just counts up how many neighbors it has. How many others are packed into its little space. And finally, and this is the magic trick, it takes the solution's original quality score, its fitness, and it divides it by that neighbor count. And right here, this is the aha moment. Just take a look at this table. Our crowded solution is objectively awesome, right? It has a fitness of 90. But because it's in a super popular area with 10 neighbors, its shared fitness score completely plummets, all the way down to 9. Now, look at the unique solution. It's not quite as good on its own. It's got a score of 80. But it's a lone wolf. It has no other neighbors. So its shared fitness score is a massive 80. And just like that, the entire game has been flipped on its head. The algorithm now sees that unique explorer as being more than 8 times more valuable than the popular superstar. So now it's going to start prioritizing and exploring this less crowded path, pulling itself right out of that echo chamber. So we've seen the what and the how, but now let's zoom out for the most important part, the why. Why does any of this actually matter? What's the real impact here? Well, the benefits are just huge. It stops algorithms from getting stuck on those good enough answers. And what's really important is that it helps them discover multiple, different, high-quality solutions. This is so critical for complex problems that don't just have one single right answer. All of this leads to more creative, more robust, and sometimes completely unexpected results. I mean, this chart really shows you the payoff. A standard algorithm might find a solution that's about 75% optimal and then just get stuck there. And that's good, but by encouraging diversity, the fitness sharing algorithm can push right past that barrier and find a solution that's, say, 98% optimal. And that's not just good, that's great. And that gap between good and great, it's not just a number. In fields like engineering or finance or scientific research, that gap can be the difference between a small improvement and a genuine game-changing breakthrough. Ultimately, this whole idea is so much bigger than just code. It's a principle, and it kind of begs a bigger question, doesn't it? In our teams, our businesses, maybe even in our own lives, where else can we benefit from rewarding not just the most popular answer, but the most unique one? Definitely something to think about. Thanks for joining me on this explainer.
Okay, about this video, okay, I think it got very, very basic concepts, and also some of the things are very simplified. Just for instance, penalizing the fitness with the number of neighbors. Just it's not like that original concept, but okay, but it speaks about niches and it got some basic concepts. So it's good for in a general way, but okay. This graph comparing the standard GA with the fitness genetic algorithm, I don't know where they got this. To be honest, I never saw this, so I don't know if this has any scientific reason. And okay, so no details about the way that the sharing is implemented and the distance is evaluated and so on and so on. So if you really want to implement a genetic algorithm with fitness sharing, okay, you have to look elsewhere, not in this video, okay? But to know about what is the crowded and the sharing and the niching, it's okay, it's very nice, okay? Thank you for watching.